Hi everyone, so in this video I'm going to explain how the periodic table can be used to help you to write electronic configuration and how electronic configuration can be used to know a little bit more about the element. So these are the objectives that is going to be addressed. So describe periodic table as a method to classify elements. Okay, so elements in the periodic table, as you know, are classified according to proton numbers. Okay, so atomic numbers or proton numbers. So they are arranged in order, in increasing proton number order. And how we're going to use this to predict the properties of the elements. And we're going to see metals and non-metals in the periodic table. And relationship between group number, valence electrons, metal, non-metal character. Okay, so let's see the periodic table. So the periodic table is going to classify elements according to their trend in properties. So what happened was that when Dmitry Mendeleev he was the scientist who brought all these elements together and classified them. When he classified the elements, he grouped them according to properties that they had. So we find that elements in the same group, for example, have similar properties. And as we go across a period, so remember that the period, these are the periods, the horizontal, the rows, they are the periods, and the columns, they are the groups. So as we go along in a period, we see that the trend, we see that something is going to increase or something is going to decrease. So there is a trend, and when we look at down a group, we see that there is a trend also. So we're going to use the position of the elements in the periodic table to be able to predict the trend of these elements. So just remember, so these are the groups. So let's do this. So these are groups. So group 1, group 2, group 3, 4, 5, 6, 7, and 8. Okay, so group 8. We are for now going to ignore these elements. Okay, not concerned about them for now. And remember that these are the periods. So that would be period 1, where there is helium. Actually, hydrogen should be in period 1, should be a little bit on top here. So period 1, period 2, period 3, period 4, 5, etc. Okay, so horizontal, period, vertical, groups. Okay, let's see what they mean now. Okay, so number of electrons found in the outermost shell in an atom is called number of valence electron. Let's say you have a couple of atomic structures. Okay, so these are a few drawings of the atomic structure of a few elements. So let's see what's the valence electrons. So all the electrons that you see in yellow, they are the valence electrons. Valence electrons are found in the outermost shell. So if we look at lithium here, so lithium, that's the outermost shell. The last shell is called the outermost shell, and the electron which is found in the last shell is called the valence electron. So that's the valence shell, okay, and this is called the valence electron. And how many valence electron we see here? So lithium, valence electron, there's one of it, okay. If we look at aluminium, last shell has 3, so that's the last shell. Last shell has 3 electrons, so number of valence electrons is equal to 3. Oxygen, 1, 2, 3, 4, 5, 6, so there's 6 electrons in the outermost shell, so the valence electron is 6, number of valence electron is 6. Fluorine, 1, 2, 3, 4, 5, 6, 7, so there is 7 electron in the outermost shell. Calcium, that's 2 electrons in the outermost shell. Okay, make sure you know how to draw these diagrams well. So What does these valence electrons mean? So the number of valence electron or outermost electrons, that's another name for valence electrons. Valence electrons are called outermost electrons, and outermost electrons, number of valence electrons, that's equal to the group number. So whatever group it is, it will have that number of valence electrons, and whatever valence electron it has, it will be found in that group. Let's see. Lithium has one valence electron, so it should be found in group 1. Let's check. Lithium, you see here, it's found in group 1. Let's see aluminium, 3 valence electron, so it should be found in group 3. Group 3. So aluminium, group 3. You see, well, actually these should be Roman numerals, okay? So aluminium is found in group 3, so that's correct. Let's see oxygen. That's oxygen. Oxygen, it should have, let's see, oxygen, it is found in group 6. It should have 6 valence electrons. 6 valence electrons. Matches, so group 6. Fluorine, let's find fluorine. Fluorine is in group 7, so it should have 7 outermost electrons. So see, 7 electrons. So this is found in group 7. Doing fine till now. Calcium is found in group, so calcium is found in group 2 here. So you see 2. So it should have 2 valence electrons. See, 2 valence electrons. So it is found in group 2. Or you could do the other way around, because it has 2 valence electrons, it is found in group 2. Okay, so this is what we learned from that. So let's see these little questions. Lithium has 1 valence electron, so it is found in group 1. Element X, so we don't know what it is. It has 3 electrons in the outermost shell, so it should be in group 3. How many outermost electron does bromine have? Let's look at bromine. Bromine, here, it is found in group 7, so it should have 7 outermost electrons. Now, elements with smaller number of electrons are usually metals, and elements with larger number of electrons are non-metals. So that's a rule that applies, that we observe that elements that have group number that are in group 1, group 2, and group 3, they are usually metals. There are a few exceptions, of course, but they are usually metals. So if you have an element that has outermost, that has valence electrons 1, 2, or 3, that element is a metal. Let's see. So lithium, 1 valence electron, it's a metal. Aluminium, 3 valence electron, it's a metal. Oxygen, it has 6 valence electrons, not a metal. So anything that is above 4, they are non-metals. So oxygen is a non-metal. Group 7, more than 4, so that's a non-metal. Calcium, that has 2, so it's a low number, so that's a metal. Okay, so anything that has valence electron 1, 2, 3, these are metals. Anything that has valence electron more than 4 is a non-metal. But what about those with valence electron 4? Well, some of them are metals, some of them are non-metals. That's why I'm ignoring it right now. So, like, you'll see carbon, silicon, metal, these are non-metals, but lead and tin, these are metals. But then silicon and germanium, we can't really say if they're metals or non-metals because they have both properties, so they're actually metalloids. So that's why I'm ignoring group number 4 for now. But this applies. 1, 2, 3 are metals, 5, 6, 7, 8 are non-metals. So let's see the periodic table here. Okay, so in the periodic table, you see there is a staircase line. That staircase line that you see, this separates the metals and the non-metals. So everything that is in dark here, they are metals. And everything over here, these are non-metals. Now, that line, actually anything that lies on the border of that line, they're actually metalloids. They share properties of metals and non-metals, so they can be a little bit confusing. So these, we'll call them, anything that is on the borderline of that staircase line has both properties of metals and non-metals. So they are called metalloids or semi-metals. Okay, and then everything here, the pale ones, so these are non-metals. Hydrogen, it's in the corner. Hydrogen is a bit, sometimes it's classified as a metal, sometimes it's classified as a non-metal. Actually, it's difficult to classify it because it has, it can have properties of metals, it can have properties of non-metals. So I'm going to abstain from classifying it, so just leave it that way. Some resources classify it as metals, some classify it as non-metals. I would consider it, for the syllabus purpose, I would consider it as a non-metal. But again, that's just for the purpose of the syllabus. That's it. Okay. Now, you're going to find the group number of the following elements and state the number of valence electron. So go ahead, find the group number and find the valence electrons. That's your work. I'm going to correct that and send you feedback on it. Use a periodic table to fill in the table below. Okay, I think this you can do it as well. And once you've done that, you should be able to do this graph. I'll ask you to do this graph in your copybook. No need to draw the grids. You can sketch it. Okay, I'll just to help you plot a number. So you'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For the first 12 elements. So you have these proton numbers, and then number of electron in outermost shell, you should have 1, 2, 3, 4, 5, 6, 7, and 8. It doesn't go beyond 8. You can't have more than 8 electrons in the outermost shell. So that should help you. So get the numbers and then you can plot the graph. Just plot it in your copybook. Okay, and you send me an image. I'm going to correct that for you. Right. Now, this is very important. Now, for any electronic configuration, the last number, that's the valence. That's the electrons in the valence shell. So these are called the valence electrons, and the valence electron will tell you the group number. And if it is from 1 to 4, so generally if X is 1 to 4, valency would be equal to X. I think we did that when we did that in Form 3. So hope you still remember it. If you don't, okay. So any electronic configuration that ends with these numbers 1, 2, 3, 4, the valency of that element would be equal to the valence electron. Let's see a few examples. Let's say 2, 8, 1, 2, 3, 2, 2, 8, 2, 2, 8, 8, 2 and 2, let's say 6. Okay, so you see that's the last electron. Okay, so that's the valence electron. It's less than 4, therefore valency is equal to 2. This one less than 4, so valency is equal to 3. Here valency would be equal to 1. Here valency would be equal to 2. If we have 2, 8, 4, valency would be equal to 4. If you still remember, valency is the combining power, which means that how many bonds it can form, which means that how many other atoms it can bond to. So that's valency. So, right. But if that last number is more than 4, so in this case it's 6, then valency is not going to be equal to 6. Valency would be equal to 8 minus 6. In this case would be equal to 2. So in the case where x is greater than 4, so 5, 6, 7, 8, valency is 8 minus the outermost shell. Okay, so let's say you have 2, 7, then valency would be equal to 8 minus 7. If you have 2, 8, 5, then valency would be 8 minus 5. And if you have an element that has electronic configuration 288, okay, so last shell is completely filled, valency would be 8 minus 8 would be equal to 0, which means that valency 0 means that it is not able to form bonds. So it's not going to bond with anything. It will exist all alone. Okay, so we're going to see why in the next lesson. We're going to see why it's 8 minus this number. Okay, so for now just learn it that way. You're going to complete this table. So find these elements from the periodic table. Find these elements from the periodic table, the electronic configuration, which group they are found, group number, valence electron, and valency. Okay, so complete this. Next lesson we're going to see noble gases.